decode, recode into same variable, recode to different variables. All facilities available in this menu bar. But our focus is to, it is very important tools, it is the analysis. Then we have to go to analysis, then descriptive statistics. So then we go to the frequency, which is the frequency. In frequency, whenever we have to click the frequency, this one small window will be open here. And as per your requirement, see, in our this questionnaire or this data set, there are two types of the data set. One is the qualitative data set, another is the quantitative data set. Like this, this symbols is related to the quantitative form of the data. Remaining is the qualitative form of the data. And like first is the gender. Gender is the, we have to click here and select this arrow, and automatically this variable selected here. Again, we have to interested in like faculty wise, then educations, then job satisfaction. As per your requirement, we have to select these variables, and we are interested to find the frequency. Frequency, or we are interested to some chart. Which type of chart? If you want bar chart, pie chart, histograms. Okay, so we are interested in the bar diagram like this. Click here. Bar diagram, bar chart, and bar diagram with frequency or percentage. As per your requirement, we have to select any one. So we have to bar diagram, bar chart with frequency. Okay, continue, and we have to click here OK. Like there are in SPSS, there are two windows. One is the input window, another is the output window. This is the output window. Within second, some chart and some graphs, this SPSS is generated. See, what is the interpretation of this tables? So N is the sample size, valid sample, and missing values. Like this. This is the one summary statistics table. So there are only 4 variables we have to select in SPSS. So first is the gender of the respondent. There are 100 samples. Is there? No missing values. So for faculty of the respondent, again 100, no missing values. Suppose only 2 missing values is there, no observations is there. We have to take care, SPSS take care 98 and 2 are missing, like this. Then education of the respondent, 100, and similar as the job satisfaction is the 100. Now, this is the frequency tabulation. It is the tabulation of the data. Tabulation means it is the male. How many male in my data? There are 52 males. This is a count. Frequency means it is the count. Female, it is the 48. What is the percentage? What is the percentage? It is the 52 and 48 percentage. And this is the valid percentage is the cumulative. As per whenever we have to find out the median, median of the data, that time we have to use the cumulative frequency. If you are interested to develop some models, statistical models, right? Modeling purpose, that time we have to use the cumulative. As per your requirement, only in your research, only you have to take, this is the male, female, frequency and percentage. Okay. So this is my first variables data. My second variable, faculty of the response. The art student is 28 students. Arts are the 28. Suppose commerce is the 41 students out of 100. Okay. And science is the 31. Science is the 31 out of 100. This is the percentage of the outcomes. Okay. Education, again, PG is the 22 students. PhD is the 50. Net set is the 20. And total is the 100. And second, last question is the like job satisfaction questions. Yes, we are satisfied. The respondent is the 57 respondent saying that we are satisfied. But 43 respondents are not satisfied. Needs jobs. So this is the tabulation of the data, and similar is the as per your requirement. This is the visualization of the data. It is known as the graphical representation of the data, like this. And if you want, suppose, sir, we want frequency, then we have to double click here, and then we will go to the elements and show the data label. Okay, so this is the percentage we have to showing here. So similarly, as per your requirement, we have to draw the graphs. Okay, so this is the basic. Within second, these outcomes is generated as spaces. Then we will go to our actual spaces window. Again, suppose, no, sir, we are interested to we want only male analysis. Then we will go to the data. See what happened. We have to take the select the cases. Select the cases. And we have to select the cases. Then we have to click if conditions. If conditions. And we have to click if. Then as per your requirement, we have to select. Suppose we have to select the gender. Male and female is there. Track here, and less than 2 means only one is present. One is the male. Okay, these conditions, and continue it. Okay, then we will go to the data. See here, this is the crossbar is there. Means what is the meaning of this? See here, the 2 means 2 is the female. Female data is not considering here only, but presenting the female. Only male data is considered. Like then we will go to the analysis like this. Go to analysis, descriptive statistics, then frequency, like this. Similar variables is there. Then we have to again click. Then we get the outcomes. Outcomes, how many? Only we have to considering male data. Only 52. Right? 52, gender of the 52, because we have to apply the conditions. We have to apply the यहाँ पे हम only male का data we have to consider here, only male, but female data is present in my data. As per your requirement, age wise, again we have to select it. Otherwise, salary, if you want to, how many male is more than 52,000 payments. Height wise, weight wise, as per your requirement, we have to select the if conditions, and then we have to analyze it. Like only male arts is 13. These are the only male data analysis. Similarly, we have to only one graph is there. Like otherwise, we have to remove all these. Then again we'll go to the data view and select the cases, and all cases. We have to select all cases. Again, our original data will be ready to analysis purpose. Right? Then next question is, Sir, we are interested to find the mean mode measure of central tendency and dispersion. As per your requirement, firstly, we identify of the data. See here, the statistical tools is depend upon the nature of the data, types of the data. If our data is qualitative, that time we use the measure of central tendency and dispersions. Right. So then we will go to the analysis, then again descriptive of statistics, and again we will go to the descriptive. Again we will go to the descriptive. So which variable we have to select? Like age, we are interested the mean of the age group, height of the age group, beginning salary, mean of the beginning salary, average, right? Then we have to select this, then this, then this, right? Then we will go to the option. Then we will go to the option. See, this is the measure of central tendency and dispersion. As per your requirement, we have to click here. If you want mean, yes, we have to click here. If you want sum, then we have to click here. If you want standard deviation, if you want maximum, minimum, variance, range, standard, as per your requirement, we have to select it, and only you have to click OK. Then okay, then we get the outcomes in systematic manner. We represent the in systematic manners. See, this is the representation. Descriptive statistics. Within one second and one table, it to visualize the data. See what is the interpretation of this? Age of the respondent. Okay, how many sample size? 100 sample we have to select. Minimum value is 23. Maximum is 58. Sum is this. Mean is mean average of the age, average age is 37. But minimum 23. Maximum 50. Mean is the standard deviation of the data. Deviation of the data is this. Deviation of the this. Like so, this is the which data is consistent as per this parameter. As per our parameter, minimum deviation is the consistent parameter, means height of the respondent is very less, is very small. So this data is consistent. Current salary and is the very high variations will be there. Current salary and the beginning salary. The variation is high. As per your requirement, we have to apply the CV or standard deviations. It's right. So these are the basic. Sir, if suppose if you want cross tables, आपको अगर cross, if you want cross table, then we will go to the descriptive statistics, cross tables, right? Then again we have to open the window. आपको यहाँ पे cross table किसका किसका होना, which wherever we have to select. Suppose gender, no problem, we will go to there. Then sir, we are faculty wise, no problem. Column, we have to faculty. Okay, then okay, then we will go to the outcome. These are our cross tabulation. It is known as the cross tabulation. Gender of the respondent. So male and female. Faculty of the respondent, like male in arts faculty 13 respondent will be there. In commerce 22, in science 70, and female is 15 in arts. In commerce it is 19, like science is the 40. These are the cross tabulation. No, sir, we want like male faculty and also satisfy level or also PC level. Then again we have to triple filter. Then we will go to the again data. Then we will go to analysis, descriptive statistics, then cross tabulation. Then what? It is the cross tabulation. This another one filter. If you, as per your requirement, you have to select like education. Education. Then we click OK. Then we get the outcomes. Then we get the outcome like this. PG, gender, male
मला
and
शर्वरीचा
hello. Any doubts? Okay. This is the PG, male and female, and this row represent the faculty of the respondent. Arts, commerce, science, like total. PG, male, female, male, female, male, female, PG, PhD, next. So this is a very simple analysis. So these are the tabulation. These are the basic as per your requirement. So the next is the sir we have to use the correlation, regression, right? If you want to sir we have to analyze we set the hypothesis. Okay, all that things. Also we have to use this software which is very useful for you. Then we will go to the analysis. This is the actual data. Okay, this is my actual data, and we are interested to analyze the correlation between variables. So firstly, we know what is the correlation between variables. What is the correlation means what? What is the correlation? You know what is the correlation? Correlation. The co means two. The relationship between two variables. The relationship between two variables. Firstly, we identify the variables which relation is correlated to each other. Co means two. The relationship between two variables, it is known as the correlations. Right? So which type of relation? One variable is independent, another is the dependent, or vice versa. Means one value is changed, automatically affect on another value. Right? Temperature is like the height and weight of the person. Height and weight of the children's. Height is increases, weight is also increases. Supply and demand, such type of correlation. Sometimes it is positive correlation or negative correlation. So correlation lies between -1 to +1. So we have data. So firstly, we identify which variables are correlated to each other. In this example, height and weight are the correlated to each other. Right? So we check. It is correlated to each other. Yes, it is correlated. How much correlated to each other? Then that time we have to use the Carr-Pearson method. We have Carr-Pearson method to check the relationship between two variables. Then we will go to the analysis. Then comparison general, like this correlation option is there. Correlation is also classified into basically two parts. One is the bivariate data, another is the partial. Partial means we have another third type, three types: bivariate, partial, and multivariate. So bivariate means only we have two variables must be there. Partial means it is the multiple regression, a multiple correlation, but some variable are partially correlated. It is partially. Suppose there are 5 variables. Out of 5, 3 variables are correlated to each other. So it is partial correlated. Multiple correlation means what? More than 2 variables is there, but these two variables are correlated to each other. So it is known as the correlation. It is known as the correlations. Okay. So we'll go to the correlation options. Bivariate data will be there because we have only two variables. One is the height, another is the weight. Okay. Then we have to select height of the person and weight of the person. See, before analysis, firstly we know what is the correlation, what is the range of the correlation, what is the positive correlation, what is the negative correlation, all that things. Okay, see, this is the Pearson Kendall Spearman. Pearson, if our data is which type of data? Our Pearson is Carr Pearson data. Carr Pearson method. Carr Pearson, our data is quantitative form of the data, no quality. Qualitative form of the data, that time we have to use the Spearman. We have to use the Spearman. And regression and other advanced tools, whenever we have to use the mixed data, that time we have to use the Kendall's correlations. So maximum time we have to use the Pearson and Spearman rank correlation. Then this is the both data is quantitative form of the data. Then we have to click here Pearson and options will be there. Okay, no, all is clear. Okay, no problem. Then we have to, okay. Then we get the correlation of the output. See here. See, this is the height of the respondent and height of weight of the respondent. See, this is the one matrix. The height of the respondent to height of respondent. Correlation lies between -1 to +1. If what is interpretation? If our data is represent one, means highly correlated, means which is 100% correlated to each other. But these values is 0.725. 0.725 means what is your interpretation? This is the positively correlated, strongly positively correlated, but it is the 0.725. It is the data is correlated. Means remaining data out of 100, right? Means this is the 0.72 means near about 28. 0.28. It is the uncorrelated to each other. It is uncorrelated. 7.72 is the correlated to each other. Yes, height is increases, its weight is also increases. Only it is correlated to each other. It means it is the 0.72 correlated to each other. Also, weight and height is also correlated. It is right. So this is the interpretation of the correlation of the data. Basically, two types of the correlation. One is the positive correlation, another is the negative correlation. What is the positive correlation? Both variables are increases. Both variables are decreases. It is known as the positive correlation. Or another types, for example, height and weight. Both variables, height is increases. Automatically, child weight is also increases. What is the negative correlation? Negative correlation means what? One value is change, another values is change. But which type? One values is increases, another value is decreases. It is known as negative correlation. It is known as negative correlation. Example of the negative correlation, right? One value is increase, another value is decrease. Give me one example, anybody? Negative correlation. Please give me one example, negative correlation. So this is the basic tools. The next question is, sir, how to analyze, when to use the t-test, parametric and non-parametric test. Then okay. Then I will share my PPT. Wait. Wait. 1 minute. So the next concept is the hypothesis testing. Hypothesis testing, we know what is the hypothesis. So basically, hypothesis, basically two types of the hypothesis. One is the null hypothesis, another is the alternative hypothesis. Null hypothesis means there is no significant difference between these two. Okay. For example, parametric and non-parametric. Parametric means we check the assumptions of the parametric. We check the assumptions. We check the normality of the data. We check the homogeneity of the data. And then we check the independency of the data. And then we decide our data is normally distributed or not. Right? Then, firstly, before that, we set the hypothesis. There are two types of the hypothesis. First is the null hypothesis, another is alternative hypothesis. In null hypothesis and alternative hypothesis, first step, there are 7 steps in the hypothesis testing. The first is the formulation of the null and alternative hypothesis. Firstly, we set the null hypothesis, then alternative hypothesis. Then second step is the specification of the level of significance. Level of significance. As per your requirement, as per your data, we said it is the, I have confidence, my data is reliable, 95%. Means my 5% level of significance we have to allow. Sometimes what happen in, especially in life sciences, in medical sciences, the data, reliability of the data are 99%. It's only level of 1% level of significance we have to require. The level of significance is depend upon our data. Our data. Okay. Accuracy of the data. Okay. So this is the, in social sciences, maximum time 95%. I have confidence my data is reliable. Is 5% error will be there. So you decide as per your requirement. So what is the level of significance? Then third step is the selection of the test statistics and its computations. In manually, we had to calculate t-test, chi-square test, like this f-test. But whenever we had to apply the statistical softwares, before applying the test, firstly, we decide which statistical tools is appropriate in my hypothesis. In comparison purpose, comparison purpose, and our data is, if comparison purpose, we apply the t-test. See, the t-test is classified into 3 types of the t-test. The first is the one sample of the t-test. One sample t-test. Second is the 2 sample t-test. 2 sample t-test. And third is the pair t-test. These are pair t-test. More than 2 samples, then that time we have to use the ANOVA, analysis of the variance. Means ANOVA means the extension part of the t-test. So we decide, if we check the comparison, we have 1 sample, then that time only 1 sample t-test. We have to check the, suppose we have one product, Bajaj and Honda. Bajaj's claim is, sir, my product is good. Honda's claim is, sir, my product is good. So how to decide which is the best product, right? So that time we have to use the two sample t-test. Then we set hypothesis firstly. The both product are
Share.
no different. Means there is no significant difference
Share.
between.
Sir,
Yes,
please change
The
the
screen
slides, sir.
stop share.
slide is okay. Now,
Yes, sir. Now visible, sir.
okay.
Yes, thank
So,
you.
so
No, sir.
these are the 7 steps in the research process. First is the formulation of null and alternative hypothesis. The second is the specification of the level of significance. The third is the select of test statistics and its computations. So this third step is depend upon your hypothesis. For example, suppose you have suppose Bajaj and Honda two-wheeler. The Bajaj company claims, sir, my product is good. Again, claim Honda is claim, no, my product is good. So we are researcher. So how to decide which is the best? So that time we set the hypothesis first. So what is the hypothesis? We set the hypothesis. There is no significant difference between Bajaj and Honda. Bajaj and any two products. There is no significant difference between these two. This is my null hypothesis. And what is the alternative hypothesis? There is the significant difference between these two. And then we select the level of significance. 5% error will be there, means 95%. Then we have to collect the data. What is the mileage of the product? What is the average of the product? Average, like this, all that things we have to collect the data. And then we decide there the data is, I have confidence my data is 95% correct, but 5% error will be there. And then we have to apply such type of data. That time we have to apply t-test. That time like two sample t-test, two independent sample t-test. Bajaj and Honda both product are the different. And then we have to apply, and then we check which is the best. Okay, so first we decide, or otherwise we check the association between variables. We check the dependency between variables. That time quantitative data, qualitative data, two variables will be there, and comparison not will be there. It is the we check the association between variables. We check the independence between variables. That time we have to use the chi-square test. Okay, so as per your requirement, as per your hypothesis, we have to decide the proper statistical test, and then finding out the critical value from the table using the level of significance, sampling distribution, and its degrees of freedom. If you have to calculate the you have to calculate all manually, that time 4 step will be used. Otherwise, in software already we have to click there, then we get the all that things, level of significance, sampling distribution, like all that things we have to probabilistic with tabular value will get. Then fifth is the determination of the significance of the test statistics. So we have to use the statistical software. That time we get the significance values. If these values is less than 5% level of significance, then we say, yes, there is our alternative hypothesis is accepted. Otherwise, our null hypothesis is accepted, right? So it is depend upon our level of significance and significance values. And then we take the decisions like this, H naught is accepted or rejected as per your conclusions. Then we have to write the conclusions. These are the 7 steps in the hypothesis test. Then we will go to the one by one. Parameters and statistics. 1 minute, please. Okay. What is the parameter? And what is the statistics? Parameter, yeah, suppose data is two types. One is the overall sample data, sample based data. Another is the population based data. Overall population is included. That time we say it is the parameters. The statistical measure namely means standard deviation, variance, correlation, it is any statistical tool. We have to calculate, estimate. If they are calculated based on the population, we have to calculate on the base of population are called parameters. The second is the statistical measures. If they are obtained based on the sample, sample is the part of population. Along they are called the statistics, or they are called the statistics. Null hypothesis, we know what is the null hypothesis, what is the alternative hypothesis. And after this, then we have to select. We have to parametric and non-parametric test. Parametric test means what? Parametric tests are those statistical tests that assume the data approximately follow normal distribution. Or otherwise, we have to some other. Normal distribution means what? Our data follow normally distributed means first is our data must be quantitative form of the data. Quantitative, not qualitative data. Our data must be quantitative form of the data. And this data follow normally distribution. Normally distribution means we take the graph like this. That time we say it is my data is bell-shaped curve. If my data follows such type of data, then we say it is the normality. I mean, another so many method to check the normality of the data. Normally, oh yes, my data is normally. Shimurang test will be there. We check the QQPP plots. Otherwise, in simple mid mode median of the data is say approximately same. Then we say my data is follow normally distributed. Otherwise, the alternative is non-parametric test. What is the non-parametric test? Are those statistical tests that do not assume anything about the distribution followed by the data. If my data is not normally distributed, then we take the transformation of the data. After transforming the data, my normality is not satisfied. My normality is not satisfied, means my data is abnormal. That time we have to use the non-parametric test. Got it? When to use the parametric, when to use the non-parametric test. After transforming the data, again we draw the graph, again we use various statistical technique to checking the normality. That time again my data is not getting the normal distributed. That time we will go to the non-parametric test. This is the distribution free test. It is known as the distribution free test. So these are the basic. It is very important. Parametric, if you have data, which type of data? First condition is the data must be normally distributed. No, first condition, my data should be quantitative form of the data. Quantitative form of the data. Then quantitative means it is the measurable form of the data. And this data must be satisfy normality. If these two conditions are not satisfied, okay, then do not use parametric test. If first condition is satisfied, but second condition is not satisfied, that time we take the transformation of the data. We take the transformation of the data. Again, we have to check my data follow normally distributed or not. If that time again my data is abnormal, not satisfy my assumptions, my conditions, then we will go to the non-parametric test. Okay, so this is the parametric test and non-parametric test. So which are the parametric and which are the non-parametric test? Pair t-test, unpaired t-test, all t-test. It is the parametric test. One-way ANOVA, Pearson coefficient, Pearson correlation. It is the parametric. It is the parametric test. What is the non-parametric? Non-parametric is the Wilcoxon sign rank test, Mann-Whitney U test, Kruskal values H test, Spearman coefficient. These are the non-parametric. So many, but these are the very important tests. These are the non-parametric tests. So when to use? Whenever we have to check the comparison before and after data, that time we have to use the pair t-test. And if the assumptions are not satisfied, the alternative is Wilcoxon sign rank test. Unpaired test, unpaired means like this before, like Honda and Bajaj, both are the product. Then that time we have to use the unpaired t-test. Unpaired means it is t-test. If these assumptions are not satisfied, then we will go to Mann-Whitney U test. One way it is a Kruskal value, Pearson. These are the non-parametric and parametric tests. Okay. So these are the assumptions. These are the assumptions of the parametric test. Normality, homogeneity or homogeneous of variance, independency and outliers. We have to check normality, homogeneous. The sample data comes from the population with the same variance. So then it is known as the homogeneous, independency and outliers. These are the normality. Okay, again, see there. This is the parametric test. These are the non-parametric. These are so it is an independent test. If these assumptions are not satisfied, then Mann-Whitney test we have to use. Pair t-test, Wilcoxon sign rank test. These are the parametric and non-parametric. This is the two sample t-test. This is also two sample test. More than two, that time we have to use the ANOVA, Kruskal value, repeated measures of ANOVA. And these are the parameters. So the next is the start. What are the assumptions and when to use the t-test? Okay. See, this is the t-test. Basically, this is the which type of test? This is the parametric test. T-test is used to test. So what happened? We have to suppose data. We have to lots of data. So we know which statistical tools we have to apply. This is the very best applications, statistical comparison purpose. Okay, two groups will be there. And this data is quantitative form of the data. Okay, the t-test is used to test whether mean of the two group is same or different. Mean of the two groups are same or different. That time we have to use one sample t-test, independent t-test, and pair t-test. Pair t-test. These are the three types of the t-test. And then next is the let one by one we have to discuss. What is the one sample t-test? One sample t-test has only one samples. One sample t-test has only one sample. If test whether the sample mean is equal to specific the value. Okay. So this is the one we have to take the one example. So what are the assumptions of the one sample t test? See, it is very important to check the assumptions. How the maximum times we do not check the assumptions, and then we have to apply. Software is there, and we have to take the value and insert the values and analyze. Then yes, sir, we get the result. It is wrong to check the assumptions of the data. So what are the assumptions? Whenever we have to apply the one sample t-test, before applying t-test, we check the assumptions. If 3 assumptions or 4 assumptions are satisfied, then we will apply the t-test. The first is the variable must be continuous or interval or ratio, means quantitative form of the data. The data must be quantitative. In data science, in machine learning, it is the metric form of the data. The data must be satisfied interval or ratio or quantitative form of the data. Then second, the observations are independent of one another. It is not dependent to each other. The data must be independent. Independent means it is not dependent to previous value. Right? Independent means it is not dependent to previous. Suppose, for example, the first value is 5. The second observation is 7. The next observation is 9. The next observation is 11. This is the dependent. This is the dependent. But what is the independent? First value is 5, second value is 8, third value is 12, randomly. So these observations are independent of one another. The third assumptions are the variable should be approximately normally distributed. So many methods to checking the normality. So to check the normality of the data, or we take the graphs of the data. If bell-shaped form of the data, then we say it is the approximately bell-shape of the data. Then we say it is my data is normally distributed. And last, the variable should not be contain any outlier. Outlier means the extreme value. If your observation, suppose each and every value is near to mean, one value is very away from mean, very high level difference between them. This is the outlier. It is the extreme value in the observations. Outlier means it is the extreme value in the observations. So these are the assumptions. If these 4 assumptions are satisfied, then we will go to the apply. For example, this is the one example. This is the example. Like one Philips company has launched a new brand of light bulbs. Right? This is the example. The Philips company has launched a new brand of light bulbs and claimed that under normal circumstances, the average life of the bulb is 1000 hours. A retailer wants to test this claim and has taken a random sample of 10 light bulbs. He tests the life of the light under normal circumstances. Got it problem? The Philips company has launched a new brand of the light. So, which be Philips company is launched a new brand of light bulb and claim that under normal electricity supply, normal circumstances, the average life of the bulb is 1000. His company's claim, but retailer is interested. He want to test the claim. Yes, his company's claim is really true or not. Then that's why he select random samples of the bulb, and he tests under normal circumstances. The life of the bulb, 10 samples he selected. The first life of the bulb is 800 hours. Second is 750, 940, 970, 9 like this, 790, 980, 820, 760, 1000 hours, So these are the and his hypothesis is right. So this is the problem. Then how to analyze such type of problems? Then say this is the sample. The life set of the 5% level of significance. Okay, the company's claim is testing whether the light bulb have the life is. Company's claim is that my product life of the bulb is 1000 hours. So what is the null hypothesis? Null hypothesis is, see, this is the one sample t test. Only we have one samples. The company's claim is the life of the bulb is 1000 hours. What is the alternative? Yes, alternative is opposite of the null hypothesis. There is the alternative hypothesis. The life of the bulb is not is equal to 1000 hours. And this is the manual. Okay. Then we check. Okay. Then we have to check. So see, this is the one sample t test. When to use the, we get the idea how when to use the one sample t test. Okay. After this, then we'll go to the SPSS. The another one is another assumptions is the assumptions of the independent of the t test. Independent of the t test. When to use the independent of the t test? The again same, the variable must be continuous. Okay. Two observations are independent. The variable should be approximately normal, same similar previous. The variable should not contain any outliers. And last is the very important when to use this. The independent variable must consistent of two independent groups. In previous example, in previous test, only we want one sample t test, only we want one. But now here, consistent of two independent group must be there. Independent group must be there. That time we have to use the t test. These are the assumptions. And what is the hypothesis of these assumptions? There is no significant difference between mean of these two groups. A and B group is there. And we have to check which is the best, the average of the A group, the average of the B group, which is the best. So that time there is no significant difference between A and B. And what is the alternative? There is the significant difference between these two. Okay. So when to use these assumptions of pair t test, the independent sample must be same. Interval means quantitative form of the data. The observations are independent. The dependent variable should be approximately normal distributed. Both variables are. The dependent variable should not be contain any outliers. The last is changed. The independent variable must consist of related two group or matched pair. Means when to use, suppose before and after data. Before training, we have to collect the data. After training, same parameter, same machine or same parameters is there. Before and after, we have to data. That time we have to use the pair t test. So these are the assumptions of the t test. So then I will start here to how to analyze. Okay. So this is what is the hypothesis? There is no significant difference between two group mean before and after. So one case study example, the company selects salesmen random and their sales figure of for the previous month are record. Then they go training course devised by the business consultant and their sales figure for the following months. Means like this is the previous month and following previous month, last month sale and current month sale. After training, what is the difference? There is any sale increases or there is any significant difference between these two or not? That time we have to use the pair t test. Okay. So then I will go to SPSS. 1 minute. Final sample. One minute. I will check. So got it? When to use the t-test? There are basically three type of the t-test. Got it? See, this is the one example. So which type of example? This is the we have some problems. Life of the bug. Okay. Okay. So it is usual for you. Life before, after like this.
Yes, sir. Is visible.
So
Yes.
see, this is the in your previous example, life of the bulb. Right? This is the when we had to use the one sample to tell. Firstly, we check the normality of the before like this, previous, following, life of the bulb. This is the example. So firstly, we check the normality of the data. So how to check? Then we will go to the analysis, descriptive statistics, explore. Explore of the means what? We have to explore. This is the one window is open. We have to select the life following previous month sale, life before, life of the bulb, right? This is the we have to select here. So dependency. Then we check the normality. Then we go to the plots. So this is the one window we have to open. And now here we have to interested to check the histograms. And then we check the normality plots. We are interested to find out the normality plots or normality test. Then we continue here and okay. Then we get the outcomes here. This is the first assumptions we have to check that my data is normally distributed or not. Then valid, this is the life of the, there are 10 samples, the percentage number of sample is this, the missing is the percentage. I think I'm missing is some dots is there. There are 20 sample. Actually, valid is 10. Okay. So this is the mean of the data like this. So this table is the very important. Testing of the normality table is the very important. And we have to considering my data is 95% is correct. 5% error will be there, means my level of significance is 5%. Shipro will test and Colombo Simro test. These two tests are the checking the normality, but which test is valid? Simro will test is the reliability, high reliable test. See, in this test, the significance values is the very important. The significance value is 0.200 and Simprovic test is the 0.154. And this both values is greater than 5% level of significance. 5% means 0.05. These two tests are greater than 5% level of significance, means if these significance values is greater than 5% of level of significance, means normality will be there. What I am saying? These significance values is greater than 5% level of significance, means 0.05, then we say normality is present in my data. If these values, suppose sir, this is less than 5%, this is the greater than 5%, so which is the best? The SIMRO will test is the reliable test. We have to go to the SIMRO will test. Okay, then another way is, this is the one test to checking the normality of the data, and this is the graph. This graph is also very important. These each point near to this line, near to a linear form, then we say that my data is normally distributed. Okay, so this data is normally distributed. Okay, so this is the means my data is C. The data is quantitative form of the data. It is not qualitative. Quantitative form of the data. First assumptions is satisfied. Normal independent performance is independently. Then normality must be there. Normality bhi hai yahan pe. Normality will be there. Then next is we test the hypothesis. Then we will go to the analysis. We go to compare the mean. We go to the compare the one. Which sampling? One sample t-test. We have to click one sample t-test. One sample t-test. What is the assumptions? The company's claim is? Kya? Company claim 1000 hours. Life of the bulb is 1000 hours. Life of the bulb is 1000 hours. And we have to select previous life of the bulb. We have to select this. And then okay. Then we get the output. And this is the very important interpretation of the output. In previous normality, the level of significance is greater than 5% level of significance, then we say my data is normally distributed. But now here, this is the t-test, one sample t-test interpretation. Life of the bulbs, sample is 100, its mean is this, standard deviation, standard error this. The t values is this, degrees of freedom, 10 minus 1, n minus, n minus 1 means number of observation minus 1, this is the 9. Significance values. See, these significance values is here. Which type of significance is less than 5% of level of significance? Got it? What is your interpretation? What is the hypothesis of this problem? The bulb of life is equal to 1000 hours. What is the alternative hypothesis? The life of the bulb not is equal to 1000 hours. Not is equal to 1000 hours. And this is the, we have to collect the data. And what is your interpretation? See, these values, there are two, these values is less than 5% level of significance. This values is less than 0.05. Means this values is 0.05. These are the less value. Means my company's claim is false. My null hypothesis is rejected. Alternative hypothesis is accepted. This is my conclusion. Got it? Any doubt? Any doubt? Here some error will be there because some confusing points. In normality testing, these significance values is we want greater than. If greater than 5% level of significance, then we say there is normally distributed. Now, whenever we apply any statistical test, hypothesis testing, that time our significance values is less than 5% level of any level of significance. Suppose we are to considering 1% level of significance. Sometimes we are considering 5% of level of significance. Now here we are to considering these values is less than, then we say null hypothesis is rejected, alternative hypothesis is accepted. Means what is your interpretation? The company's claim is wrong, fail. The life of the bulb is not is equal to 1000 hours. This is the scientific interpretations. Okay, so this is the one sample t-test. So another way the when to use the like before, after, when to use the pair pair t-test, there are two in previous example, we had to considering previous month sale and following month sales. This we have data, then we had to apply the pair t-test. When to, what is the hypothesis of this? There is no significant difference between after training, before and after training, previous and following, there is no significant difference between sale. This is the null hypothesis. And what is the alternative hypothesis? There is the significant difference between previous and current month. Then which hypothesis is accepted and which is the rejected? Then that time we'll go to the analysis. Again, we have to compare the mean. And these are the pair t-test. When to use pair t-test of the previous month, right? And then following pairs. So these are the, then we have to click here. Then we get the outcome. This is my outcomes. Otherwise, firstly we check the normality, same process. I am not checking here, but otherwise we have to check the normality like this. We check the normality. First we check the normality of the data. Explore. Previous and this and this. Plots. Yes. Continue. Okay. Then we get the outcomes of the data. Both. See here. Month following the previous month. See here. The both significance. See here. The first is the both value. Now here these values and these value both are greater than these value and these value. See these two values is greater than 5% level of significance. These values is greater than 5% level of significance, means the data is normally distributed. And we observe our data. Data is metric form, quantitative form of the data. Independent performance. Each and every assumption is satisfied. Then we have to apply the pair t-test. And this is our pair t-test interpretation, the outcomes of the in this value. See, we have to check the observe it. We have to observe the last value in pair t-test. It is the 0.143. This value is, what is the hypothesis? Previous month and following one, there is no significance. Selling the product, there is no significance. And now there is the significance. Now, what is your interpretation? Our null hypothesis is rejected. Alternative hypothesis is accepted. So these are the pair t-test. Now next, these are the very simple. It is very useful for you. Okay. see, these are the normality. Like similar, we have this type of data of okay. So another one minute. Within 5 minutes, I will stop here, no problem. Okay. So another, it is very useful for, especially in management and commerce use, chi-square test. Chi-square test. It is not chi, it is the chi-square. When to use the chi-square test? Chi, we check the so many application of the chi-square test, but in the major times in maximum researcher, we have to use this test. The data must be qualitative form of the data. Data must be qualitative form of the data. And two variables must be there. The checking purpose of the this when to use, we check the association between, there is any association between two variable or not. There is any independency between these two variables or not. That time we have to use chi-square test. Chi-square test. What are the assumptions of the chi-square test? Assumptions. The sample method is simple random sampling. Because it is the probabilistic sampling must be there. Simple random sampling. Sampling, it is the probabilistic sampling, non-probabilistic sampling, simple random sampling, stratified sampling, cluster sampling. So these are the simple random. Simple random sampling also classified into two parts. Simple random sampling with replacement and without replacement. Okay. So the first condition is data must be generated of simple random sampling. The second, each population is at least 10 times. The frequency is must be 10 times. The larger is respective samples. The variable under study are each category. Each categorical data must be there. If the sample data are displayed in contingency table, cross table, the expected frequency count for each CM. What is the expected frequency? So this is the OI minus AM. This is the formula. What is the OI? OI is the observed actual data. And what is the AI is the expected. This is my observed value. And this is the expected. These are the expected. So these are the, if these assumptions, the frequency count each cell of the table is at least 5. At least 5 must be there in the contingency table, value must be 5. If greater than, it is best, but less than, that time we have to pull the value. Two variable we have to add. These are the assumptions. If these assumptions are satisfied, then we have to use the chi-square test. Again, chi-square test, we have to use, suppose for example, we check the association between male and female and its job satisfaction. There is any association between job satisfaction and education. Okay, in our previous data, we have to consider it. One minute where, okay. Okay. Suppose this is our data. is job satisfaction and its education are both variables here in this. Education are qualitative data, qualitative, and job satisfaction is also qualitative form of the data. Then where our hypothesis is there is no association between job satisfaction and education. And what is the alternative? There is the association between these two. And these are raw data. It is not. Then we have to go descriptive statistics, cross table. Wait 1 minute. Then my education we have to select education. Where is education? Education level. Okay. And gender. Okay. Then we will go to the exact. No, exact. No. Then we will go to the statistics. Sorry. Then we will go to the exact statistics. A chi-square test is there. We have to select this and continue. Then okay. Then we get the result. Then we will go to the result. See, these values is again less than 5%. There is no association between these education and job satisfaction. मीन्स इसका मतलब ऐसा होता है जॉब और एजुकेशन इसमें कुछ रिलेशन नहीं है because these values is greater than 5% level of significance. This values is greater than 5% level of significance. This is the brief introduction of this software. It is very useful for you. You means it is everybody. It is a researcher, especially in researcher. So you have now I'm stop here. Only 5 minutes is there. If you have any question, please ask me questions. We have only 5 minutes. You have any questions related this topic or any statistic related? Please tell me. काय क्वेश्चन असेल तर विचारा. Any questions?
No question, sir.
No, sir.
No, sir.
No, sir, no.
Can I leave?
I would like to conclude this session by thanking Zadhav sir for your guidance. Role of statistic in research, type of data and practical demonstration of SPSS is very well explained. Thank you, sir. Thank you.
Thank you. Thank you, sir.
Thank you, Jadhav sir.
Thank you, madam. Thank you.